Hey there everyone, I'm Michael, and welcome to another episode of Coding Sins, or the 10 Commandments of Programming. In this episode, we're going to be doing commandment number 2. Thou shalt never Yandere Dev. Now, who is Yandere Dev? Well, I'm not going to go into the full backstory of Yandev. You can Google him and you can find out who he is. But either way, he's the developer of this Unity game called the Yandere Simulator, and long story short, without going into too much of the drama, people have decompiled his code, and it is not great code at all. It is awful. It is sinful. It is the worst code you will ever have to face in your life if you ever have to face Yandere Dev Code. And actually, not really, because I found something even worse. And it's actually a game that I used to work on, originally developed by Philip Adams, called ShiftOS. If you want an example of what Yandere Dev Code is, this is it. As you can see, it's a massive wall of text. Literally, there's not a single line on the screen right now, other than the 4 at the top, that does not have a full length of text on it. This is a 1440p display, by the way. And it gets worse when you realize that it's a 21:9 display, and I'm only running it at 16:9, and even still it doesn't have enough space to display all this code. Anyway, so what we're looking at here is actually the implementation of something called a skill tree. In ShiftOS, it was called the Shiftorium, and the way it worked was the more you use the in-game operating system, the more code points you earn. And with those code points, you can buy Shiftorium upgrades. And as you buy Shiftorium upgrades, more Shiftorium upgrades become available to you. In the game dev industry, this is what we call a skill tree. It has things, or it's the code behind things like the evolution system in Prototype 1, various games that have you buying different abilities for your character using some sort of experience points. That's called a skill tree, and this is an implementation of one that is very Yandere Dev-like, and it's bad. So this is the code that handles the buy button. So when you click the buy button, it has to go through each upgrade and check and handle its buy capability. This code is over 150 lines of code long. Then we have the handle upgrade list method, which goes ahead and displays which upgrades you can buy based on what you've already bought and what's available. This code is over 500 lines of code. Which, by the way, if you want to check the lines of code of a method, one easy way you can do it is to collapse it in Visual Studio or Writer and subtract the larger line number from the smaller line number, and the difference is going to be the amount of lines of code that that function takes up. But anyway, the handle by method is not that long, but that's fine. But yeah, the problem areas here are with the handle by and the handle upgrade list methods. So let's try to build our own skill tree that would satisfy the needs of ShiftOS without being Yandere Dev-like. Because, you know what, we don't want to sin. We don't want to be guillotined by a programmer lord. Anyway, what we're going to start out with is we need to define a save file of some sort in the theoretical space. That is, we need to define some list of upgrades that we have already purchased, that we have unlocked. So I'm going to do that very easily by creating a list of UIDs. I'm using UIDs because they can be unique and they can be auto-generated, and they're going to be what we store in the save file to know which upgrade is installed, or is unlocked. What upgrades are unlocked, and it's a good way to obscure which upgrades are which, so you do have an inherent advantage there when it comes to anti-cheat. Anyway, we're going to create a new GUIDs list. And there we go. Good to go. Now, next we need some sort of value to keep track of how much skill points we have. So var skill points equals 0L. That's going to be a 64-bit integer. Really, you don't need it to be a 16-bit or 64-bit integer, but it can be a 16-bit integer, or 64-bit integer, sorry. Actually, I decided the last minute that's going to be 32-bit. Anyway, so we have our save file here. This is our game save. This is our player information, too. Anyway, the next thing that we need to determine is how upgrades are handled. Now, if you're Yandere Dev, you might go ahead and create some sort of method that does all that work, just like OS. But no, we're not going to do that. We're going to use this wonderful thing that came out in the 80s called a class. We're going to create a class called upgrade. Also, please fact check me if classes didn't come out in the 80s, or if the concept of object-oriented programming wasn't around in the 80s. Do let me know, but I would hope that it was, and it would make it even more funny if it was. Anyway, so we're going to create this upgrade class, and this is going to hold all of the information about our upgrade. The first of which is going to be its in-engine ID. That is the ID that it has in the save file when it's unlocked. Of course, all upgrades most likely have a name and a description, so we're going to add those as well. And they have some sort of cost associated with them, whether it be money or code points or skill points or experience points or whatever you want to call it, it's going to be called a cost. This is how many points you need to unlock the upgrade. Now, the way we check if an upgrade is purchased is fairly easy. All we need to do is take in the list of already purchased upgrades and check if our ID is in that list. Now, you could do this outside of the class. For example, I could have some sort of active upgrade here. By the way, null as upgrade here is a way to allow me to use var while initializing over null. It's a stylistic choice. I just don't like using explicit types when I'm declaring local variables. But obviously var active upgrade equals null is not going to compile without that as upgrade specifier at the end. So that's why I need to do that, and it's a stylistic choice. Anyway, we could just simply check if GUIDs contains the upgrade ID. And that will tell us definitively that that upgrade is actually available, or is actually purchased. But, and I meant to do active upgrade, not upgrade. Anyway, that'll tell us definitively, okay, this upgrade is in fact purchased, we can use it, we can apply it, we can do whatever gameplay tweak we want based on this upgrade being bought. This'll work, but it's going to lead to code duplication, because you're going to probably need to check this in more than one place. You'll need to check it in your UI when you're displaying the upgrade, when you're actually clicking the buy button, or determining whether that buy button should be displayed instead of an already unlocked piece of text. You're going to be using this code whenever you're checking if the upgrade's there so you can apply its gameplay attributes and whatnot. So it's going to cause code duplication, and you might eventually change how you determine how upgrades are purchased. So we're going to use a function for this. Not a property, because we need to take in some outside value, but we're going to use a function. So public bool is purchased. We're going to take in, for now, the list of GUIDs. As a list of purchased upgrades. And we're going to simply return whether the purchased list contains our ID. If it does, then we've been purchased. Now, this is all well and good. We have a pretty basic skill upgrade system going on here. We can have a master list of upgrades, for example. We're going to declare a new list of upgrades called master upgrade table. And there we go, we have our list of upgrades. So we can actually loop through that list and check if any of them are available. Now, an upgrade is available if it's not purchased. So let's define that method here. Public bool is available, and because is purchased requires the upgrade list to determine whether we have the upgrade in our list, is available needs that as well. So we're going to give it our list of purchased upgrades, and we're simply going to return whether it is not purchased. So now what we can do is, let's say that this master upgrade table does have a list of all upgrades in the game. Maybe it gets it somewhere from the file system, or from some other piece of code, or an embedded resource, or a Unity asset, or whatnot. And either way, we're going to pretend that this list has a bunch of entries in it. And all we have to do to display them is create a for each loop that loops through the upgrade master table. And we only loop through the upgrades where they are available. And from here we can display their name and their skill point cost. Pretty simple. So then, let's refactor this a little, because now our game designer has told us, well, okay, it's great that we have this skill system in place now, but our character can upgrade his sprint speed, and once he's upgraded his sprint speed, well, he can do it again later on, to go even faster. So we're going to have up to 4 different sprint speed upgrades, and you have to buy one to get the next, to get the next, to get the next. So this means that our skill system suddenly needs to support operating as a tree, and this is why it's called a skill tree, because the upgrades, the master upgrade list, is no longer treated as a list, it's now treated as a tree. And how do we implement that? Well, in our upgrade class, we can store references to other upgrades. So what this means is we can actually store a list of other upgrades that we need. Now, our game designer probably didn't tell us that we need to store a list, but we have the option. For example, in Prototype, in order for you to buy air dash, or in order for you to buy sprint speed 3, not only do you need sprint speed 2, but you need to be you need to be progressed through a certain portion of the game to get that upgrade and unlock it, and that may internally be treated as an upgrade even if it's not displayed to the player, or it may be treated by some other means. But either way, one way we can get around that is to store a list of dependent upgrades. So let's do that. We're going to store a list of dependencies. And this can be a read-only property initialized with a new list, because we plan to serialize this later on, and we're going to read that list some other way. Anyway, I'm just talking in theory there. We're not going to deal with serialization, don't worry. But anyway, we now have, with just one extra line of code, this concept of a tree, where an upgrade can depend on other upgrades. So now we need to upgrade our isAvailable method to determine not only are we purchased, but if we're not purchased, are all of our dependencies purchased. So let's sort this whole thing out. So our default return is going to be true, because we're available if we pass any of these conditions. So the first condition is going to be that we are not purchased. So if we pass that condition, we can move on to the next condition, which is that all of our dependencies, if there are any, are purchased. because in prototype you need, actually I'm trying to think of different, it's been a while since I've fully played through the game, so I can't think of any upgrades, for example, or in the actual game, but let's say that Alex Mercer needs to buy Sprint Speed 1 and Jump Height 1 before he can buy Hammer Fist. So he requires 2 upgrades to buy Hammer Fist with his evolution points. So we need to respect that condition here and pass that condition by doing if not, or if this dot dependencies dot all, which means all of the elements in this list need to pass a specific condition for this to return true, and that condition is going to be for each upgrade it needs to be purchased. And if this is not the case, then we're going to return false. So now we have our upgrade tree. So now we have a skill tree. And so far, we have used, okay, well the class itself is, we can actually count this instead of calculating it, which is good. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 lines of code for the class itself. And our sort of mock testing code here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code. Contrast to that to the almost 1,000 lines of code that only a portion of this upgrade system in ShiftOS is. And you start to get the idea here. The idea here is that if we avoid being like Yandere Dev, suddenly our code is a lot more manageable to read. We've taken thousands of method calls and if statements and turned them into 4 lines of a for-each statement that displays our upgrades. Now, our game designer has looked at us and said, okay, I reviewed your code, you have implemented a skill system, but there's no way to buy these upgrades yet. Can you please fix that? Well, let's sort that out. All we need to do is implement a buy method. So, let's do it. Now the first thing that the buy method needs is our list of purchased upgrades, because it's going to check if it's available, and if it is, then we're going to, well, when we purchase the upgrade, we're going to add ourselves to the purchased list. And because now we're actually dealing with purchasing the upgrade, we're also going to need access to the player's current skill points so that we can subtract our value from those skill points. I'm taking it in as a reference instead of a value so that we can actually modify it inside this method. Anyway, the first thing that we need to do is check if we are available. And if we're available, then we need to check if if the player's skill points, or if there are enough skill points to satisfy our cost. Then we can subtract our cost from the skill points. And we can add our ID to the purchased list. And we have implemented a buy method, and it is only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code long. So add that to, I believe, the 25 lines of code that the class is, and you get 36. Pretty cool. Now, of course, our game designer has said, okay, well now, or our UI designer went in and said, okay, that's great that you have this buy method working, and I'm using it, and it's working great, and it's awesome, but I would like to know if the purchase was actually successful, because I got feedback from the gameplay testers saying, hey, we're trying to buy this upgrade that's already installed, or it is already unlocked, and it's not displaying an error. It's still letting me buy the upgrade, and that's not ideal. So we're gonna actually make this void function return a boolean, and if we manage to buy the upgrade, we're gonna return true, and otherwise, if we don't return true, then we're gonna end up returning false, and that way the UI designer can go in and display an error, or they can play a sound effect when the purchase is successful, and stuff like that. And that is really great. And all we have done is added 3 lines of code, and one of them is a space. Yeah. And now our UI designer is happy because, well, we're looking at his code now, and you know what he did? And you know what he did to purchase the upgrade? He did this. One line of code. Contrast that to the 200 or 150 lines of code that this handle by method is in HiftOS. So the btn by click. And let's see how big the handle by method itself is. We're going to count this. Be prepared, it's going to take a little bit. Whoops. Alright, I'm not good with Visual Studio. There's a reason I use Writer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62 lines of code. Holy God. We took that and turned it into 1. Anyway, that is why thou shalt never Yandere Dev. As always, I've been Michael. Hope you learned something. Hope you enjoyed the video, and I'll see you guys in the next one. Thanks for watching.